Ms. Humbert here, and today we're going to talk about solving systems by substitution. So this is one of the tougher parts of Unit 2, simply because it does involve a lot of algebra. So let's go ahead and take a look at our steps. So steps for solving systems by substitution. So the first step is to solve one of the equations for the variable. So we want to have y equals, or even x equals. It doesn't matter which variable, as long as one of them is solved for the variable. Taking a look at number 2, we want to substitute that expression into the other equation. So we're going to take whatever that expression is and we're going to substitute it in. That's why it's called substitution. Now what I'm talking about may not make a lot of sense right now, but it'll make more sense when we put it into practice. But it is important to have these steps written down so that you can reference them back if you get stuck. Step number 3 is to solve for the remaining variable. At that point, once you substituted it in, you should only have one variable left. Okay, and then you can substitute that value either into the equation and into either equation. It doesn't matter which one, it's going to give you the same answer. And then you're going to solve for the remaining variable. So let's take a look at the number of solutions that we can have. The first one is that having infinitely many solutions. If both of the variables are going to cancel and what's left is a true statement, then the system has infinitely many solutions. And so that means that we might have something left over that says 3 equals 3 and 2 equals 2 or something like that. Okay? So if both the variables cancel and what is left is a false statement, we have something that says 3 is equal to negative 2, 1 is equal to 4. That's never going to happen. That is not a true statement. Then we have no solution. So let's take a look at number 1. And so for number 1, we have, notice on the bottom, we have x is equal to. So let's go ahead, and we know that x is equal to this guy right here. They're equivalent, they are equal, they mean the same thing. So what that tells me is where I see x out here, I can completely take that x out. So I'm going to completely take that x out, and instead I'm going to write 2y plus 36. And then that's going to be plus 2y is equal to 8. So now, if you notice, I've taken that x out completely. When I put in that new equation, I took the x out completely. So now I'm only left with y's, and I can solve this equation. So even though I have y's, in the parentheses, I can still add my y's. So I have 2y here and 2y here. So I'm going to combine that to be 4y plus 36 is equal to 8. To continue solving for y, I'm going to subtract 36 from both sides. And then I get 4y is equal to 32, or negative 32, I'm sorry. Next, we need to divide both sides by 4, and we get that y is equal to a negative 7. So now that we know that y is equal to a negative 7, I can plug it into either equation I want up here. It doesn't matter which equation. To me, it's smarter to plug it into this equation right here, because that one's already solved for x. So when I plug in y, I have less solving that I have to do. So I still don't know what x is equal to, but I do know now that my y is equal to negative 7 plus 36. So 2 times negative 7 is negative 14 plus 36. Add those together and you get 22. So I get x is equal to 22. The last thing I want to do is write it out as a coordinate point for my answer. So x then y, because it represents a solution. So that's going to be 22, negative 7. So if we were to graph those two lines like we were doing the past couple of notes, you would be crossing at 22, negative 7. Now this is a lot more accurate than graphing. Graphing is always more of an estimate. Let's take a look at number 2. Number 2 is not solved for a variable, so we're going to have to do that. So what I notice right here is I have this x and it has a coefficient of 1. When I'm trying to pick an equation and pick a variable to solve for, I always try and look for a positive coefficient of 1. Okay, that makes it easier to solve. So I'm going to take this equation, 1x plus 2y is equal to 15, and I want to solve that for x. So I'm going to go ahead and I'm going to subtract 2y from both sides, and then I get that x is equal to negative 2y plus 15. Now that's the same as this equation right here. So now I've already used that equation, so I want to take the fact that this is right here is solved for x, and I'm going to go ahead and I'm going to plug it in for that x in the original equation. So I'm going to have 2, and then instead of writing x, I'm going to write negative 2y plus 15, because that is the same as x, so I can substitute it out. So then I have minus 3y is equal to 2. So let's go ahead and distribute this. So we have 2 times negative 2, and that's going to be negative 4y. 2 times 15, that's going to give us 30. We still have this minus 3y here. I notice a lot that students forget about that 3y, so don't forget about that 3y. So now we want to go and solve this for y. So here I have negative 4 and negative 3, so those are going to combine to be a negative 7. Then it's going to be plus 30, and that's equal to 2. So the next thing I want to do is take this plus 30 and subtract 30 from both sides. So we have negative 7y. 2 minus 30 is going to be a negative 28. So I'm going to divide both sides by negative 7, and I'm going to get that y is equal to a positive 4. So I'm not done yet. I know what y is equal to. So then if I go up here, I need to plug it back in. I can plug it back into this one, or this one. I have a lot of options. I'm actually going to plug it into that one because I've already done the work of solving for x. So I'm going to plug in for y. So I have x is equal to 2, and instead of putting in y, negative 2, I'm going to put a 4 plus 15. So then I get negative 8 plus 15, so I get that x is equal to 7. Finally, I want to write that out as a coordinate point, which would be 4, 7. Okay, I want you guys to go ahead and try number 3 on your own. My hint to you is take this equation and solve it for x before you get started. Let's take a look at number 4. Now, number 4 is actually already solved for a variable. So we can go ahead and we can do some substitution. So I know that y is equal to 4x plus, or 4 plus x. That's the same thing as y. So where I see y up there, I can go ahead and substitute it in. So I have 4 plus x is equal to 3x minus 4. So now I want to solve it for x. So I like to take the smaller amount of x's and bring it over to the side with the larger amount of x's. So I have 4 is equal to 3x minus x is 2x minus 4. Then I'm going to add 4 to both sides, and I get 8 is equal to 2x. Then I'm going to go ahead and divide both sides by 2. So here I get that x is equal to 4. So now I need to go back up here, and I can pick either equation. I'm going to just pick this one. So I'm going to plug in 4 for x. So I have y is equal to 3 times 4 minus 4. So that's 12 minus 4. So I get that y is equal to 8. So my solution then is 4, 8. Moving forward, let's take a look at these ones. So first thing we need to do is solve for a variable. So what I'm going to do is I'm going to take this equation right here, and since the x is already by itself on that side, I'm just going to get rid of the 2. So I'm going to divide everything by 2, and then I get that x is equal to 2y plus 2. So I'm going to plug that in for that x in the first equation. So then I'm going to get 3 times 2y plus 2 minus 6y is equal to 6. So now we're going to go ahead and solve that. So I'm going to distribute that in. So then I get 6y plus 6 minus 6y is equal to 6. Okay, so when I do that, 6y minus 6y, well, those are actually going to cancel out. So my variable is completely gone, and I'm left with 6 is equal to 6. Now that's that true, the what's left over being a true statement, what we talked about early in the units. So if you cancel out all your variables and what's left is true, then you have infinitely many solutions. Let's take a look at this one here. So what I'm going to do is I'm going to take and I'm going to solve this equation for y. So I'm going to subtract 7 from both sides. So that's going to give me 2x minus 7. So what I'm going to do is I'm going to take and I'm going to plug that in for y here. So I'm going to get 6x minus 3 times 2x minus 7 is equal to 24. Now I'm going to keep solving that and I'm going to distribute. So then I have 6x minus 6x minus, so this is going to be negative 3 times a negative 7, so that's going to become a positive 21 is equal to 24. Well, 6x minus 6x, again, that's going to cancel out. So our variables are going to cancel out, and we're left with 21 is equal to 24. Well, that's not a true statement. So for this one, since it's not a true statement that's left over, we have no solution. Okay, let's take a look at some of these word problems. Campus Rentals rents 2 to 3 bedroom apartments for $700 and $900 per month, respectively. Last month, they had 6 vacant apartments. So let's let X equal 2 bedrooms, and let's let Y represent the number of 3 bedrooms. So between the two bedrooms and the 3 bedrooms, we need to have 6 total apartments. Then for every 2 bedroom, we earn $700. For every 3 bedroom, we earn $900. And that has to be equal to $4,600. Now we're going to go ahead and solve this by substitution. So I'm going to take that and I'm going to solve it for y. So subtract x from both sides. So I have y, subtract x. So I get y is equal to negative x plus 6. Now I'm going to take this and I'm going to plug it in for y in that second equation. So then I'm going to get 700x plus 900 times negative x plus 6, and I'm going to run out of room, is equal to 4,600. So now I need to go through and solve this for x. So then I get 700x plus negative 900x plus 900 times 6. So 5,400 is equal to 4,600. So I'm going to add those two together, and I'm going to get a negative 200x. So I'm going to keep solving for x. So I'm going to go ahead and I'm going to subtract this from both sides. So I get negative 200x is equal to a negative 800. Divide both sides by negative 200. And I get that x is equal to 4. So there's 4 2-bedroom apartments. Okay? So next, let's plug it in to get the number of 3-bedroom apartments. So I'm going to take this and I'm going to plug it in for x up there. So then I have y is equal to a negative 4x. So I'm plugging that in instead of x, which is a negative 4, plus 6. So then I have y is equal to a negative 4 plus 6, so y is equal to 2. So there's 2 3-bedroom apartments. Okay, so let's go ahead and get this last word problem set up, and then I want you to solve the last 2. So the larger of 2 numbers is 8 more. So the larger of 2 numbers, we'll call it x, is 8 more, so it's going to be 8 plus 4 times the smaller. Okay, so 8 more than 4 times the smaller number. So y is the smaller number, x is the larger number. If the larger number is increased by 4 times the smaller, larger number, increase means add, by 4 times the smaller number, the result is 40. So there's your system right there. So this is already solved for x, so you can take and substitute it into x down there. Last but not least, I do want you to finish this problem on your own, and we will talk about them in class tomorrow. Make sure you take your Schoology quiz. Thanks for listening.